Assalamualaikum and a very good morning. Okay, in this video, I'll be covering on fundamental of testing. So basically, this is the coverage of the content. Okay, what is testing, right? Testing is a process consisting of all lifecycle activities, both static and dynamic. When you heard about static testing, what that means is that you actually do the testing without running the system. Whereas when you see or hear about dynamic testing, you're actually running the system and perform the test at the same time, right? So it's concerned about when you do testing, you have to plan first, you have to prepare, and then after that you evaluate the software products. Alright, you do testing in order to determine that you actually have developed a software that satisfy the specified requirement. Okay, and then at the same time, when you do testing, you're actually trying to show that the software that you built actually fit for the purpose, and at the same time, you do it in order to detect any defects. Right. Testing is not debugging. What that means is that testing can show failures that are caused by defect. Okay. Debugging is a development activity. You normally do it when you are doing your own programming, right? So you are doing your coding at the same time you want to fix some of the error. So that's a slightly different thing. Okay, testing is not debugging. All right, why is testing necessary? You have to do it because you cannot avoid any existence of error. Okay, you might think that there is no error, but somehow there might be error that you might be overlooked. Right. So normally this is how the failure happen. Okay. Normally it start with an error first, and then there will be bug that you will see, and then it leads to failure. So what causes errors? Okay. So it can happen during poor communication that happen between the user and the system analyst during the early phase. The system analysts understood the system requirement differently from what the users want. Also happen because of the software complexity. Some systems are very complex, where the system analyst might not totally understand the processes. Yes. It also happen due to programming errors. Maybe some logic error happen there. So miscalculation, changing of requirement. Maybe when you first do it in the first early phase, you get the original requirement right, but as you go along, there are some changes of requirement that the system analyst might overlook. Time pressure, okay, you don't have time, so basically you do it in rush, and poorly documented code, right? Okay, sometimes when you do coding, especially for the inexperienced programmer, they tend to just simply write the code without thinking about maintainability. Who's going to read the code after that? So when that happens, when there are some errors, so it will be having hard time finding the errors. Sorry. Okay, I think you have seen this diagram before. It's a very famous diagram. What is one to show is that when you think about something, the other people might have a different understanding about it. Okay, so what it shows is that when you meet the user, the user actually want a very simple system like this, but the way that the other people in the software development see it is slightly different. Okay, alright, just now you have seen the diagram showing from error going to bugs and then to the failure, right? So when you are doing testing, you are actually trying to, when an error happen, when failures happen, what you want to do is that you want to find the source of error, okay? And you want to do it the to find the earlier section. You want to do it early so that you can avoid more serious error. Okay, for example, when there are failure happen, okay, you will go back. Okay, why this? Why this? For example, incorrect tax amount calculated. Okay, wrong calculation for tax. So what actually caused this? So when you look at the defect, okay, wrong interest formula coded, and then when you go back, why this happened? Because the developer understand it wrongly and make wrong assumption. So the cause is actually unclear specification. So you try to fall back to trace back what was the real source of the error. Okay, testing objective. Why you are doing testing? You have heard about it just now. So this is a detailed elaboration of why you are doing testing. Of course, to find defect, not really to find. You want to prevent it from happen. Maybe you have found it during the first version. During the second version, you want to avoid the same thing from happening, and then you try to reduce risk of failure. Okay, you don't want the failure to happen because you have tested it. So you, when it's running at the user side, you don't want the failure to happen. At the same time, you want to build confidence. You want to release the system having some confidence because you have tested as much as possible from different angle. And at the same time, when you do testing, you want to meet contract. Sometimes when you are at the early part of the agreement with your user, you have signed a contract listing down all the requirements to be satisfied. Not only that, you need to also meet the legal requirement and any regulatory requirements. Maybe you have to follow certain standards um, imposed by the government. So you want, when you do tests, you are actually trying to check that you meet all of that. And at the same time, you provide sufficient information to the stakeholder about the quality of the system. So you can have a report with supporting with data that you can share with your stakeholder, with the owner of the system, that you have done as this much of testing. All right. Okay, this is some definition. When during testing, when you heard about quality, what that means. The easy way to understand this is that you are meeting the user expectation and needs. Okay, you are basically trying to satisfy your user, not yourself as a developer, and to ensure fitness for purpose. Okay, it can be used for the purpose of the system. Then testing, when you do testing, you are trying to find the gaps between the system to be delivered and the requirement. Okay, you are trying to match that the requirement of the system needed by the user is actually mapped back to what the system offers. Okay, when you do testing, you are basically trying to improve the quality of the system. Again, this is similar to what have been explained just now. By removing defects, you can improve the quality by meeting the user's expectation, demonstrate the purpose, fitness for purpose, and to conform to the requirement. So this is slightly similar to what was explained earlier. Alright, so when you are doing testing, there are some common principles that you need to have at the back of your mind. Right? So basically there are 7. Okay, the first one, testing shows the presence of defects and not the absence. So when you do testing, the purpose is to show the defect. Testing cannot prove that the program is defect free. Right? So when you do testing, you are at the back of your mind, you should be thinking that you want to show the presence of defect, okay, not the absence. And then the second principle, exhaustive testing is impossible. If you want to test all sorts of combination of testing, that will be impossible. It's too much. Sometimes because of the time that you have, you cannot do all. So what you need to do is that you need to do risk analysis. You should focus on what are the risks that you should be focusing on and test that more. And look at the time and budget that you have. Okay, the third principle is early testing save time and money. That's true because when you find it earlier, especially during the requirement or the analysis phase, you can avoid lots of uh, error that might happen before you actually put the system at the user side. Okay, so this is showing that if you find it earlier, the cost is less because you can fix it earlier. Alright, the fourth principle is defect cluster together. So what that means is that whenever normally the defects are actually in a cluster form, meaning that they are near to one another. Okay, they are not randomly distributed. So when you find one error at one place, you should be doing more testing at that part, that code, okay, that you found the error. Okay, principle 5. Beware of the pesticide paradox. What that means is that maybe you have write a set of test cases and it works to find the errors, and then later on you have the second version and then you run the same test case again. So what you need to do, not only to run it, but to improve the test cases as well, because there might be new defects found in the new version, even though there are not much changes in terms of in the requirement. And then in the principle 6, testing is a context dependent, meaning that um, let's say if you've been running testing for quite some time, you might be having a database of test cases, right? So when, let's say, if you are developing a new system in a slightly different environment, okay, you need to modify the test cases a bit so that it fits or it is adapted to the new environment or the new risk that the new system might be having. Okay, so you must tailor it so that it fit the new environment. Okay, principle 7, absence of error is a fallacy, right? Let's say sometimes you run the system, there is no error. That does not mean that it's, it's, it's totally good. Okay, it's 100% good. Okay, because you need to also understand that even though there is no error, but the system does not meet the user's expectation and needs, it is considered to be error. Alright, test process. Okay, let's say you are doing a test. So you should be having these processes in your mind. Okay, it's not about only executing the testing or writing the test cases. So you need to plan it first. Okay, so basically this is a general process um, that you can follow in order to do different types of testing. Of course, you need to plan it first because this is a very time consuming process and it is very costly. So you need to plan it first. You need to set the objective. What do you want to test in a clear manner and what is the scope? Right? By doing that, you can actually set the time and budget, and then you need to identify the risk and constraint. Okay, I mentioned to you that it's impossible to test everything, right? So one way of doing it is to identify what is the risk that you need to handle for that particular system, so that when you do that, you can actually focus only to solve that, to identify or to test the thing that is related to the identified risk, and then to decide the test approach, what kind of testing that you want to do, and define entry and exit criteria. Okay, when to begin the testing, when to stop it, and then you need to identify the team, how many people, what are their skills, okay, what the test resources that you need. Do you need special software for testing software? You need what kind of computer with what kind of specification, and that you need to schedule it. Okay, because maybe you have different testing running at the same time. Maybe your tester need to work during certain week in order to finish it before moving to another process. Sorry, before moving to another project. Okay, once you have tested, test do the test plan. The next thing to do is to monitor and control it. Okay, you need to monitor and document the progress. Okay, how do you want to monitor that? Okay, you can do Gantt chart. Okay, and then you need to decide how do you want to measure and analyze the results. Okay, in what form? Initiate corrective action. Okay, if there is some error with the code when you do testing, what you want to do, and you want to decide what is the action that you be followed next. Okay, now um, you want to do analysis. Okay, what that is that right now you are trying to write the test cases. Okay, so first of all you need to review the test basis. Test basis is referring to your requirement, your use case specification. So whatever documentation that you have, or maybe user manual from the previous version or the new one. Okay, so that is basically the documentation that you can refer to. And then you need to evaluate the test basis. Sometimes the requirement written is not clear, okay, because you want to test something. So the document that you refer to must be clear enough so that you can get some idea how to test the system. Right? Once the requirement is very clear, okay, you can identify the test condition. Test condition is basically what you want to test. Okay, in order for you to write your test cases. Right. And then test design. Test design is where you are writing the test cases. You design it and then you prioritize it. Okay, because there might be many test cases. So you want to you need to give the sequence. Okay, basically this is will refer to the risk that you have identified earlier. Okay, maybe you want the risk is that the system there might be problem in the, for example, let's say the system is very heavy user. It's a very system that is being accessed by many user. So you want to make sure that whenever data is being submitted, so it is in a very it can be stored in a very accurate manner. Okay, let's say that is the risk. So you write the test cases based on that risk. Okay, and then you need to identify what is data needed in order to execute the test cases. And then you design the test environment. Test environment is actually the platform that you're going to use during the testing. What kind of machine? Uh, do you need any server that runs any software that special testing software that you need to capture the data? Okay, how are you going to log? How are you going to record the results? Then when everything is ready, so the test cases are ready, right? You want to implement it. Okay, you need to develop test procedure. Okay, what is the steps which is done need to be done first, second, third, and fourth, and then by this time around you have a set of test cases already. So test suites is basically a collection of test cases. You normally put the test cases together so that it can run in one whole batch. Okay, you don't have to run one test cases at the same time. So normally combine them together and then make a command so that it can be executed all at the same time or one by one. Maybe if there is 200 test cases, this test suite is basically helping you to run all, not manually run one at a time. And then you build and verify the test environment. So you check whether the test environment, the machine that you are using is enough to run the test case, and then the test cases, and then to ensure bi-directional traceability. So by this time around, you want to make sure that um, whatever that you have, the test cases all map back to what have been planned. Okay, so that it's easier to report later on. And then don't get confused with implementation and execution. Execution is the actual running of the test cases. Implementing is basically a preparation steps before you actually execute it. Okay, test execution is the actual running of the test cases, right? So by this time around, the test cases has been run. Let's say you have written 200 test cases. So now during test execution, it is actually run. And then this time around, you'll be seeing some results. So you have to record it. And then, when you write your test cases, you have expected results. Okay. And then at this time around, you have the actual results already. So you can compare whether what you are expecting is the same as what is obtained when the test cases are run. And then along the way, when you run the test cases, maybe you will find a defect. Okay, you have to record it. As a tester, you are not the one who fixed the error. Okay, you are basically identifying the error, record it, and then you will pass it back to the developer. And then repeating test activities as a result of action taken for a defect. Okay, maybe you need to repeat some of the test cases activities. Maybe the results that you get is not good enough to stop. Okay, and then test completion is basically happen where all the test cases are run. You get the reports already, right? So you are at this point of time you are checking the report. Okay, especially the defect reports, which parts are of the code are having defects when the test cases are run. And then you want to provide a summary because you want to show it to the project manager or task manager, so you don't want to show very detailed one, so you put it in the form of a summary so that it's easier to communicate with the stakeholder. And then finalizing and archiving the testware. Okay, so all the test cases that you have, the environment that you've been used, you need to record it properly, right? So maybe you can repeat the same uh, environment when you test another set of testing later on. And then you analyze the lesson learned. Okay, what has been learned throughout the test session. Okay, what was the problem that you face so that you can avoid it from happening. Right. When you do any software activities, the important part is actually the traceability. Right. So why this is important? Because it is aiding in analyzing the impact of changes. Maybe there are some changes that you need to do during the testing, so you can check back what was the original one. Okay, whether it is the same as what the requirement has been agreed upon, and that it enhanced the auditability of the testing work product. Okay, it's for audit purpose, and then at the same time it improved the understanding of the test process reports by non-technical stakeholder. Okay, because after you finish the testing, you can actually give back the report, so the non-technical stakeholder can actually view it in the easy manner. All right, the psychology of the testing. Okay, when you have normally the best way to do testing is through independence of tester. What that means is that if you are the developer, you know everything about the code, right? So you know where might be the error happen, okay, how the connection between the codes is being done. So you know everything about the code. So when you do a testing, it's good to actually have somebody outside of the developer team. Okay, independent tester have a different mindset because they are not the developer, and they can provide an objective and unbiased analysis of the system. So because they are the outsider, they are considered outsiders. So they have not looked at the code at all. So they are totally having a different mindset. So when they test, it's more objective. Okay, they follow what they want to test. Okay, and then another psychology of testing that is normally happen is called paradox of testing, right? So what this means is that the best way, I mentioned earlier that when you do testing, you are basically trying to build confidence about the system, right? You want to feel confident that the system is good enough before you put it to the user side for operation, right? So when you find defects, basically the confidence about the system will go down, right? So when you do testing, you are basically trying to build the confidence on about the system by trying to destroy it, meaning that whatever defects need to be found during the testing, by doing so, all the fix, all the errors can be fixed before you actually ship it. So by doing that, you can build more confidence about the system. And then, sometimes they don't like tester. You know why? Because tester basically trying to reveal errors, right? People does not like their error to be revealed. So it's not an easy job, and this requires diplomacy and tech. Okay, you need to have a very good interpersonal skills. Whenever you found error, you need to have very good way of communicating the error, okay, in a constructive way. Okay, you do not attack any of the developer. You are only basically revealing the error. So hopefully this um, video is helpful for you. So basically what we have been covering just now, we look at what is testing, right? And then what cause failure. Okay, normally it starts with an error first. Okay, and then there is a defect, and then it follows by a failure. And in testing, whenever that happens, you need to find the root cause of the error. So you will go back and investigate what caused the failure, right? And then we look at the 7 principles of testing, okay? And then the processes involved in testing and the psychology of testing. Thank you.